So we're going to use volumes of revolution to find the volume of a cone. Okay, so we've got to think how we're going to set this up. So we need to rotate some sort of shape around the x or the y axis to get a cone. And the way we're going to do that is as such. I'm going to draw a little graph on here. Okay, and then we are going to draw on a straight line. Okay, pretend this is straight. And we just want to work generally with a cone. We don't want to put in specific values because we want to find the general formula. So if you think this is going to, when we rotate this shape round the x-axis, okay, so bear in mind this is the x, this is the y, we're going to get a cone where this is the top point. We're going to get a circle around here and sort of smaller circles everywhere here. Okay, this is going to be a cone. The height's going to be from this point up to this point, okay, with this point being h for the height, and then from here up to here, that's going to be our radius r. Okay, so if we're thinking about the gradient of this line, because we need a formula for y in terms of x, if we think about the gradient of this line, that is, well, it's the change in y over the change in x, so m is equal to r minus 0 over h minus 0, which is equal to r over h, and this line goes through the origin, so y is equal to r over hx plus 0. So for a rotation around the x-axis, remember the formula is v is equal to pi b to a y squared dx. So we need to find y squared, so y squared is equal to r squared over h squared x squared. Okay, so the volume of the cone, vol of cone, is equal to pi r squared over h squared. We can take that out because it's got no x dependence, and our limits are h, and this is a little bit confusing. I've drawn this to show the distance. It looks like that point's 1, so of course 0, so h and 0, x squared dx. This is equal to pi r squared over h squared x cubed over 3 from h to 0. Of course, we plug in 0, we just get 0, so we just need to consider this h, and that gives us pi r squared over h squared h cubed over 3. The h squared cancels with 2 of these h's, and that gives us pi r squared h over 3, which is the well-known formula for the volume of the cone. So hopefully you can see how we can set up these volumes of revolution to find actual shapes, because this is the type of thing you might get asked. You might just be given an equation and told which way to rotate it and between which points, and to solve that, which is nice and simple. Or you might get a bit more of a problem solving question like this. You might be asked to find the volume of a bowl or something like that, okay, and you're going to have to think about which shape can you draw to rotate. This is where math gets a little bit more creative, I guess, but once you've set up your correct shape, and there's some I was going to say there's some nice more ways to do it, I guess there could be. Once you've set up your shape, then you can, the formulation's normally quite simple after that. If you think, for example, here, we'd set up some line from here up to here, and done our endpoints on the y, we could have rotated around the y-axis and still got a cone, alright? So just, I thought it would be easier to go around the x. Yeah, it's up to you, really. Yeah, take, for example, we even took this exact same line and dotted it here, and we were rotating around this way. This, it would just become our radius. This long line, this would be our height. Okay, so that's what I'm saying. There's multiple ways you can do it, but I think I'll pick the simplest way. You got any questions on this? Let me know down in the comment section below. If you did enjoy the video, please be sure to like and subscribe, and I hope to see you in the next one.